Now we have a lens question. This one's actually a little bit of a tricky question in that the measurements and the hints of where to draw things are included in the language of the question, but it's not always really obvious. We kind of have to use a little bit of our common sense and our logic to kind of piece it together. So the first part, we have a converging lens that projects a sharp image of the object onto the screen. Now this is important, and you'll see why in a second. So we're trying to figure out the path of the two rays from the object onto the screen. So first bit is kind of straightforward, right? If this is the line that we're on, it's going to continue going straight until you reach the lens, as does the bottom ray. But here's where the sharp image comment from the instructions is actually really helpful. The fact that it's a sharp image on the screen means that that is where my light rays converge. So the fact that an image is sharp means this is my point where my projection is happening, and that is why it's a clear image, nice and sharp. So that means that from here I need to draw my rays such that they bend and meet at that point on the screen. I've drawn it a little bit off, but sort of that's what it should look like. So that's 2 marks. The first one acknowledging that they should be kind of, after they cross the lens, they should curve towards each other. So the top one should be coming down, the bottom one should be going up. And the second mark is that they meet at the screen. Then for part B, same setup, except now we have a thinner converging lens. Same positions. The thinner lens has a longer focal length. So a longer focal length means that the light rays are going to converge further away. For part A, the reason that the rays all converged here is because this is the focal point. So with this lens here, everything at the same distance means that my focal point is not on the screen, but it's actually going to be beyond the screen. It's going to be further. It has a longer focal length. So just like before, we're going to follow the existing rays towards the lens. And just like before, they are going to converge, which means my top ray is going to go downward. However, it's going to go downward at a lesser angle because I need them to meet further away. So you get 2 marks. The first mark for drawing them convergent, but at a smaller angle than they were before. And the second mark comes from having them meet further away from the screen. So with this particular lens at this location, the image on the screen would not be focused. If you wanted to focus this image, you would have to move the lens further back. That way its focal length would land on the screen. Or you can move the screen further back so that it matches the lens's focal length. Now we have a converging lens. Maybe this one, maybe not, doesn't matter. Its focal length is 10 centimeters. But the important thing here is that it is used as a magnifying glass. So whenever we have a magnifying glass, the way we use it is we have an object, and then we put the lens over it, and then we see a bigger object. But this bigger image that we see looks like it's coming from behind where we are. So like if from a side point of view, this is my object and this is my magnifying glass, then my object looks bigger, but on the same side as the object, which is, you know, like under the magnifying glass. So the object and the image are both on the same side, which means that when you have a converging lens, usually you have the image on the opposite side of the lens, unless you are so close to the lens that you end up with the image on the same side, and that happens when you are behind the lens but in front of the focal length. So if you're behind the focal length, your image will appear on the other side. If you're in front of the focal length, your image appears on the same side. So when we're describing our position for the object in relation to the lens, the object is closer than the focal length to the lens. Meaning if this is my lens, this is my object, F is going to be somewhere farther than my location. Describe the position of the image relative to the lens and the object. So my image, again, is coming from, quote unquote, behind the lens, right? If this is my eye here, the image looks like it's behind the lens, therefore it's on the same side as the object. So that's my first mark, but I also want to specify that it's behind the object, though both of them will get you the 1 mark. But the key thing is that it's on the same side as the object. And 3 properties of this image. Because it's on the same side as my object, we know from a converging lens that in order for the image to be on this side, it's because my light rays actually diverged, and therefore I had to extend them. And so my image is made on this same side as the object. And since I had to extend my rays, it is a virtual image. It's a magnifying glass. The whole reason for it is because my image is enlarged, otherwise what's the point? And it's also upright, right? We don't see things on a magnifying glass that are upside down, we see them right side up. So the image is upright.